Hello, I'm Eric. This is chapter 14, radiation, the study of how energy gets from one place to another. And when we first think of this, we think of an antenna propagating out a signal over a distance, over an area. And that's what this Poynting value measures, named after the Englishman who discovered it in 1884. So, when we first think of this for power in electrical sense, we think of voltage times current in a scalar value. And area, well, it's just area. We all know how to calculate area. So we take the E field, which is measured in volts per unit length, and we take the H field with it, which is measured in current per unit length, and multiply those two together, and you give us a scalar value of S. But if we want it directional, we can take the cross product of E and H. Give us a directional Poynting vector. Or E cross B times 1 over mu is equal to the same thing. And on a more simple terms, all we're saying here is power divided by area equals this Poynting value. So it's amazing to think that if we take an E field and cross it with a magnetic field, we'll get energy, such as how a cyclotron works, with two magnets on either side of a cylinder that has an E field propagating out into D-shaped electrodes. Also, just one other example, we have a flow of water going through two electrified plates with a magnet on the bottom. This is called magnetohydrodynamics. And you put a charge on the electrodes, you put a voltage on the electrodes, and you put, obviously it's a magnet, so this will force the water in the direction of that you have the plates oriented. So, let's work some problems. Example 14.1. Here we have let me read the problem. Given an electrical circuit, a DC voltage source, and a resistor, verify that power is equal to V times I after integrating S over the surface of the resistor. Okay, so we have a voltage source which gives us an E field. We also have current I, which gives us a B field. The B field goes around the current, or around the wire, but the only part we're concerned with is the current inside the resistor, which creates a magnetic field around the resistor. So here we have an E field going downward. We have a B field going into the board on the left hand side and out of the board on the right hand side. And we have an S field going into the resistor on all sides. So E is calculated as volts per unit length. B is calculated as mu times current per unit length, also 2 pi radius. A is radius. And S we know as E cross B. Well, it's also E times B sine theta. In our case, theta happens to be 90 degrees. So sine theta goes away. So putting S in terms of current and voltage, we say that V times I mu naught divided by mu 2 pi R L is equal to, mu's cancel, we get voltage times current divided by an area, a circular area of the cylinder of the this particular resistor. Not all resistors are circular, but this one is. So we also know power from back over here. Power divided by area equals S, so power equals S times area. Well, our area is 2 pi r times L, so we get power when we multiply the area of the cylinder times S. And when you do that, the area cancels out, leaving you with voltage times current. Now, time to work one problem. If you wouldn't mind, please check me on this one. This is 14-2. 14-2 says we have a radio station broadcasting power at 50 kilowatts, effective at 810 kilohertz. Find the root of the mean square of the E field and P field at a distance of 1 kilometer. So I put that up here. 50 kilowatts, 810 kilohertz at a distance of 1,000 meters. So we can immediately calculate S. For this, we say power divided by, using spherical symmetry, so we're dividing an area of this sphere, and it is 4 pi r squared, which after dividing it all, we get 3.98 times 10 to the negative 3 watts per square meter. So now we want E field from this. We can get E field from just having S. So we say S divided by permittivity of free space, S divided by permittivity of free space divided by speed of light will give us E squared. And after taking the square root of all that, you get 1.22 volts per meter. Now, in order to get root of the mean square from E naught, you simply divide E naught by root 2, root of the mean square. So after that, I get 0.866 volts per meter. Now, it's really easy to get the magnetic field from the electric field. I'll leave it up to you to look it up, but it's really just dividing 1 by the speed of light. So after you do that, I've got 4.081 times 10 to the negative 9, roughly 4 nanotesla. And you take the root of the mean square, I got 2.88, roughly 3 nanotesla. Alright, thank you very much for your time, and that concludes this video.